Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Field of View by Matt Tressel, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 once each. And we have magnets, where a digit in a magnet cell, M, is the sum of all digits seen in the indicated direction up to the first cell seen that contains a digit larger than M. Okay. So that means along this path, this is the sum of all digits that are seen up to the first cell that contains a digit larger than M. Huh, that's an interesting... So I guess this could be like something like 6, and then you have 1, 5, and then you could have 8 there, or something like that. Something along those lines. One thing that, yeah, because this is the sum of all the digits seen in this direction up to the first cell seen that contains a digit larger than M. So M is 6. That means it's the sum of the digits seen until it reaches a digit that is larger than 6, which would be 8. So this is an example of how these magnets work. And those are all the rules. If you like to play along, there's going to be a link in the description. I guess it can go to the end, and because there's no more digit, it's basically the sum of the digits, right? Huh. Interesting. But those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So this is the sum of basically these two cells. It can't be just one cell, because then they would have to be the same digit. So this could be anything. It's 3 through 9. So, yeah, these have to be sums. They have to be greater. So 9 can only be if the remaining digits in the row or column can add up to 9, right? So you could have 3 digits at most. So this is 3 through 9 for the same reasoning. But the thing is, if it's further away, like if you could have potentially 7 digits in it, you cannot have 9 as the last digit, or as the digit in the magnet. And you always are going to have the sum of... These are always going to have the sum of 3, at least. So we have those, I guess. So you're always going to have 2 digits along the path which are smaller than the magnet. Because you can't have 1 digit, because if it's 1 digit, it would be the same digit as it. So these have to be smaller than this. These must be smaller than that. These must be smaller than that. These must be smaller than that. So must these two. These two have to be smaller than the magnets on the outside. This is 2 smaller. This could be a 9. So this could be 9 because it could be 3 digits. This could be a 9 because it could be 3 digits. This cannot be. That can't be. These are too smaller, too smaller. So this is going to be greater than this. Interesting. So these two are less than that. This must be less than that. So this must be this is essentially double of what this digit is. So this has to be 6 or 8, which makes this 3 or 4. Right? Because this sees that digit and then sees those digits. And it cannot be 8. If this is 8, then this is smaller than 8. This is going to be 4. It's going to be the sum of those digits, which is going to be greater than 8. So this must be 6. This must be 3. We have 1 and 2 here. So this can't be 3 or 6. If this were smaller than 6, then it would add that, and that's not going to add up to 6. So this has to be 7 or 8 here. If this one includes these two and these, the problem is it's going to have to include all 3 of those. So that would be 6 plus at minimum 1, 2, but this can't be 9. So therefore this cannot include this one. So this must be larger than this, which makes this an 8. So this is 8. This is 7. This is larger than that. So we have 9 here. Because it can't be the sum of 3 digits. This has to then be, to add up to 8, it must be 1 with 2, 5, or 3, 4. Which means, and this is 1, 6, 2, 5, or 3, 4, but it cannot be 1, 6 because of the 1, that has to be one of these digits. This is 8, so that eliminates 8 in the rest of the box. So this must be 2, 5, or 3, 6 here. Sorry, 2, 5, or 3, 4. No 2 here, though, because of the 1, 2 pair in the box. That leaves this as a 6. So that's 6. Okay, remaining digits of column 8. 4, 5, 8, 9. Obviously, this digit must be smaller than that, so this cannot be 3 or 4. This cannot be 8 or 9 here. I guess it could be 8, actually. So this is 4, 5, or 8. If you have 5, it has to be 4 and 1. If it's 6, it's 4, 5, 1, or 4, 2. If it's 7, it's 4, 3, 5, 2. If it's 8, it's 5, 3. If it's 9, it's 4, 5. Or it's not 8, 1. Okay. One of these is going to have to be bigger. And this cannot be the sum of 3 digits. So then this must be bigger than that. So this is double this. Because this is the sum of these 2 digits. And this must be the sum of these 3. Well, it doesn't have to be double. It has to be at least double, though. Which means this cannot be 3, 4, 5. This can't be 5 because double of 5 would be 10. So this has to be smaller. This could be larger. So it's the same thing with this scenario, right? One of these is the sum of at least 3 digits. We don't know which. Oops. So no 8 here. These two are smaller than this. So it could be 3, 1. Okay, so this cannot be the sum of 4 digits. So this digit is greater than this. So we have this is larger than that. So it is the sum of 3 digits, which this must be the sum of 2. This is 3, which is E. So this is 3, 4, which means this cannot be 3, 4 as a pair. It's 2 and 5 here. That means this cannot be 2, 5. Again, if this is 3, this is 1, 2. If it's 4, it's 1, 3. Either way, this cannot have a 1. So this becomes a 3, 4 pair. in row 4, which eliminates 3 and 4 in the rest of the row. So this is 1. This can, if this is 4, that would be 1, 3 here, but that would eliminate all possibilities for that. So this must be 3, and this is 1, 2 as a pair. 3 eliminates 3 here, so that's 4. So this is then 6, because it cannot be the sum of 4 digits. So we have no 3 here, no 6. This must be greater than 6, so it's 7, 8, or 9. This can't be 4 or 6 anymore. Remaining digits in column 2. 4, 5, 7, 8, 9. 4, 5, 7, 8, 9. 4, 5, 7, 8, 9. This is the sum of these two. So it cannot be 3. This can't be 9 then. Remaining digits of box 4 are 5, 6, 7, 8. Okay, this cannot be the sum of 3 digits, because if it were the sum of 3 digits, it's 1, 5, 6 at minimum, which is 12. So this has to be bigger than this. This can't be 3, can't be 4, can't be 5, can't be 9, because this must be smaller than this. No 5 or 6 then, this is 7 or 8. 6 would be 1, 5, 7 would be 1, 6, or 2, 5. Okay. So this is the sum of 1, 2, and 3. If this is 5, this is 1 and 4. If this is 7, this is 2 and 5, or 3 and 4. If this is 8, you could have 1, 7, 3, 5. If this is 9, you could have 4, 5 there. This can't be 6 here. These two must be smaller than it. And if this is smaller, this would be the sum of all of these digits, which is too large. So this must be bigger than this. This cannot be 3 then. This cannot be 8. This can't be 3 because it can't be the sum of 1 or 2. So this is bigger than this, which means this can't be 4. This can't be 7 then. So 4 would require 1, 3. 5 would require 1, 4 here because we have a 2 here. Either way, you need a 1, so this has to be 1, and this is either 3 or 4. This cannot be 1 in something, so this is at minimum 2 and 3, so no 3 or 4 there. We have a 5, 6, 7 triplet in row 5, which eliminates 5, 6, and 7 in the rest of the row. So this can't be 5, 6, or 7, it's 8. Therefore, no 8 here, no 8 here. Remaining digits in row 5 are 3, 4, and 9. So 3, 4, 9 here, 3, 4, 9 here, and 3, 4, 9 here. To add up to, if this were 5, this would have to be 2 and 3. We don't have a 1 available anymore. So to add, for 3 digits to add up, that doesn't work. This must be greater than this. So this is at least 6 through 9 here. So if this were 5, this would have to be 4, and that would be 1, 3, but then this would have to be 2, 3, which is impossible. So this cannot be 5. So it's either 2, 4, or 5 here. We have a 4, 5 pair in column 6, which eliminates 4 and 5 in the rest of the column. So this can't be 4, it's 3, which makes this one 4, which makes that not 4, it's 5, which 2 and 5 add up to 7. So this is 7, this must be greater than 7, so we have 8, and 9. Remaining digits in column 6 are 6, 8, and 9. Okay. 7 eliminates 7 here. This is 6 then, which makes this 5, and 1, which makes that 2. So there's no 5 here, no 5 here. This cannot be 6 or 7. So this is 5 or 9 there. 3 eliminates 3 there. So this is 4, 5, or 9 here. Okay, so let's check. Let's we don't really need these colorings. We don't need the reds now. Let's just see which ones. 3 is the sum of 1 and 2. 6 is larger, so that checks out. 8 is the sum of 1, 4, 3. 9 is larger. That checks out. 7 is the sum of 5 and 2. 8 is larger, so that checks out. 7 is the sum of 2, 5, which 8 and 9 is going to be larger. 6 is the sum of 5, 1, and 8 is larger. We don't know about this. So for this to be 9, it would have to be 2, 3, and 5 at minimum, which is too big. So this cannot be 9. This has to be 5. And therefore, this must be 2 and 3 here. We can't have 3 here because of 3 in the row, so that's 2, that's 3, which means this cannot be 3 or 5. And then this must be larger than 5, so it's 6, 7, or 9. So then that's satisfied. 3 is a sum of 1 and 2. 7 is going to be larger. That's satisfied. 6 is a sum of 1, 2, 3. 7 is larger, so that's satisfied. 4 is a sum of 1 and 3. 7's larger. That's satisfied. 6 is a sum of 2, 1, 3. It's 7, 8, or 9 is going to be larger. Okay. This can't be 5 anymore. Five eliminates 5 here. So this must be smaller than this digit. So these two must be smaller. And this is then 7, which makes this 1, and that's 8. Wait, why can't 9 be there? 9 could be there. Okay, so this is 7 or 8. This has to be not any of these. It's 8 or 9. So we have 1 or 2 there. Never mind. Okay, so then that's that scenario. Okay. 5 eliminates 5 here. So one of these is going to be the sum of the others. If you cannot have 6 here, because that would of course require this to be 1, 2, 3 if that's the case. What about 7? So 6 doesn't work if this is the greater one. It can't work if it's the smaller one either, because 1, 2, 6 would have to be less than, would equal 9, but this can't be 9 because that would have to be the sum of all of these digits. So 6 here doesn't work because that would force this to be 1, 2, 3, and you can't have 1, 2, 6 adding up to a non-9. So 6 doesn't work. 7, what about 7? 7 would require 1, 2, 4, but then 4 is not the sum of 1 and 2. So therefore 7 doesn't work. So this must be 4, which makes this 9, which makes this 4. So no 9 here. This is 4, which makes this 1 and 3. This can't be 1 because of 1 in the column, so that's 3, that's 1, which means this can't be 1, that's 2. This is the sum of these 3 digits. This is 8, that's 7, this must be 9. 8 eliminates 8 here, so that's 9. No 8 or 9 here. No 8 or 1 there. No 3 or 4. This can't be 4, so this is 5. So 5 and 2 at minimum add up to 7, which makes this a 6. So no 7, 8, 9 here. No 7, 8 here. No 7, 8 here. Whereas 9 in column 2, it must be here. So this is 9. So again, 1 and 3 is the sum of 4, and 8's greater than 4, so that's satisfied. 5 and 2 add up to 7, and it goes to the end of the line. 1, 3, and 4 is equal to 8, and 9 is greater than 8, so that's satisfied. 2 and 7 add up to 9, and it goes to the end of the line. This can't be 5 or 9. This can't be 5. This can't be 5. This can't be 9 here or 9 here. This can't be 9 here. What are the sums? If this is 7, this has to be 3, 4, or 2, 5. It cannot be 2, 5 because of 2 in the column. So this would have to be 3, 4, 7. If it's 8, it's 3, 5, 8 because it can't be 4, 4, 8. So this is 3 either way. So we have that as 3. 6 here eliminates, that's 3 in the corner. We celebrate because we're close to solving it. 7 and 6, 2 eliminates 2 here, so it's 1 and 2. There is no 9 here. Remaining digits of row 6 are 8 and 9. Remaining digits of column 1. We have 1, 4, and 5. This can't be 1, so that forces this to be a 4, 5 pair, which eliminates 4 and 5 in the rest of the row, and therefore this is a 3. And this can't be 1 here, so that's also 4, 5, which makes this a 1 here. Remaining digits in column 3, we have 2, 7, 8. And this can't be 2, so that's 7 or 8, which forces this to be 2 here. Remaining digits of... Let's do row 8. We have 5, 7, 8. Okay, so, and this can't be 5 or 7 here, so this must be 8, which makes this 9, which makes that 8. So this is 5, 7, 5, 7. Remaining digits of column 5 are 1, 6, 7. This can't be 7, though, because of 7 in the row. Okay, where are 1 and 2 in? 8 eliminates 8 here. Where are 1 and 2 in row 9? They cannot be here because of the 1, 2 in the boxes, and they can't be here because of 1, 2 in the column, so this must be a 1, 2 pair here. That leaves the remaining digits where... Remaining digits of row 9, then, are... Well, specifically here, it's 5 through 9. In box 9, it's 4, 5, 7, 9. And this cannot be 5, 7, or 9, so that forces this to be 4, which makes that 9. There's no 4 or 9 here. 4 eliminates 4 here, so that's 5, which makes this 4. 3 and 4 add up to 7, and that's satisfied now. And the rest is just normal Sudoku. 7 eliminates 7 here, it's 8. 5 eliminates 5 here, so it's 4 and 5. 5 eliminates 5 here, so it's 7, 5, which makes that 7. This can't be 7, it's 6. This can't be 6, it's 8, which makes this 6. 6 eliminates 6 here, so it's 1. This can't be 1 or 6, it's 7. 2 can't be here. And we have 2 and 8, so this must be 8. That's 2. No 6, 7, 8, 9 here. It's 5. 2 eliminates 2 here, so it's 1 and 2. That leaves this digit as a 9. 8 eliminates 8 here. It's 4. This can't be 9. It's 8. 4 eliminates 4 here, so it's 3 and 4. And remaining digits, we have 1, which can't be here, so 1 must be here. This is 9, and 3 and 6. So that's 6, and that's 3. And that's a solution. Fairly straightforward. I feel the magnet cells are pretty restrictive in how they're, like, because they can't ever be 9 except if they go to the end of the grid, right? With 3 digits. So you can only use them really, like, in certain places. because you can only have 3 digits that are going to be smaller than it. So, but it's an interesting new rule set. I'm curious if it can be actually expanded more. My hunch is it's probably pretty too restrictive to be used in that many puzzles, but that would just be my hunch. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.